Hello, my name is Lane Kuykendall, and today I'll be talking to you about mountain lion populations in California and the relation to human mountain lion interactions. Some background real quick. The management of mountain lion populations in California has undergone many changes. In 1906 to 1963, there was actually a bounty system on mountain lions, which paid people per mountain lion killed. In 1919 to 1959, the state had actually employed mountain lion hunters. And in 1963 to 1970, they ended the bounty system, but they still allowed hunting with no bag limit. In 1970, the state designated the animal as a game species, which meant that people had to go buy a hunting license and a tag, but there was still no limit. And in 1971 to 1986, the state enacted a statewide moratorium which stopped the hunting of mountain lions due to public concern for the population. And in 1990, the California voters passed Proposition 117, which permanently banned the hunting of mountain lions in the state. And it must be highlighted that this was a proposition that was passed off of public opinion and not management biology. The population of mountain lions in California, I'll be referring to a retrospective look at mountain lion populations in California 1906 to 2018 by Justin A. Dillinger and Stephen G. Torres. In this research paper, Dillinger and Torres investigate the population of mountain lions in California from 1906 to 2018. They use the mortality rates of lions collected from California Department of Fish and Wildlife, the Department of Transportation, the United States Department of Agriculture, the California Highway Patrol, Wildlife Services, and county courthouses. The CHP and Caltrans provided data on mountain lions killed by vehicles statewide. They used data collected on mountain lions purposely killed for bounty or depredation reasons from 1906 to 2018, and the data on mountain lions killed from vehicles from 2009 to 2018. They state in their paper that there were some assumptions made in the data that can result in underestimates or overestimates, like the fact that there are human factors, like the fact that mountain lions have been killed from poaching, which there is no obvious accurate data on. Dillinger and Torres used a discrete population growth model modified to include rates of human-caused mortality. A population growth model is a mathematical equation that allows scientists to predict populations of a species. To do that, they normally use factors such as birth rates, death rates, and carrying capacity. Normally, a population model is used to predict future populations. However, since the most concrete data for mountain lions is what we presently have, Dillinger and Torres took a standard population growth model and modified it to work backwards. The model they used is this one here. In this equation, lambda is the annual intrinsic growth rate, which is the maximum rate maximum rate a population can grow when there is no limiting factors, which they found to be 1.4 with a standard deviation of 0.03. D is the combined number of individuals that were taken purposefully or accidentally per year. M is the coefficient of additional mortalities, which is things like poaching and disease, which was found to be 0.1 with a standard deviation of 0.03. To estimate the change in growth from year to year, they had to establish a mean intrinsic growth, which determined to be the 1.4 or 1.14, apologize. And to estimate the number of mountain lions killed by vehicles from 2000 to 2014, they took the mean number of lions killed by vehicles from 2015 to 2018 and added a standard deviation of plus or minus 10%. Then from every decade preceding that, they decreased the mean by 10%, which gave a rough estimate of how many mountain lions were killed by vehicles in each decade. They did this to account for the decrease in traffic working backwards. The coefficient of additional mortalities was found to be an average of 0.1 with a standard deviation of 0.03. Then they transformed this original equation into this one here, where N(t)-1 is the population of the end of the year, is the population at the end of the year accounting for the annual growth additional mortality, and individuals taken per year. They chose the upper limit and lower limits of 5,000 and 1,000 respectively based on data collected by other researchers of potential population maximums and minimums in the state. They then ran an equation at t equals 112, which is the time from 1906 to 2018, 1,000 times with varying values for lambda with the standard deviation, and they got this graph here. So looking at this graph, we can see that the population had a steady decrease from 1906 to 1970, which correlates with the bounty period and the hunting period of mountain lions. It can also be seen that around 2000, the results begin to diverge a bit. The replications of the equation on the low end, which is 1,000, show that the population will start to slowly decline, while the replications from the range 1,500 to 5,000 show that there's a steady growth in the population. Based off the results, it seems clear that there is a steady growth in the populations since 1906 to 2018. Human mountain lion interactions, I'll be looking at the paper Temporal Trends and Drivers of Mountain Lion Depredation in California, USA. And I need to specify real quick that when I say human lion interactions, I'm not talking about instances where humans have been attacked by lions. I'm referring to instances where lions have destroyed property such as killed livestock or pets. In these instances, depredation tags are issued to the landowners, where they are allowed to lethally remove that lion that has killed that animal. 72, the regulations around depredation permits have been relatively consistent, which means the data from 1972 is really consistent. However, it must be underlined that from 2006 to 2014, there was a transition from paper to electronic reporting, which could have resulted in a loss of reports. Analysis, they found 7,719 verified instances of mountain lion depredation events in California from 1972 to 2019. 3,394 resulted in the lethal removal of lions. Of those 7,719 events, 61.1% were small hoof stock, which is things such as sheep and goat. 13.1% were large hoof stock, which are things like cattle. 10.4% are pets, which are dogs, cats, chickens, ducks, or anything like that. And then 15.4% did not have data that specified what the animal was. The graph here, we can see very obviously that there is an increase in the total depredation from 1972 to 2019. There is a pretty significant drop from what looks about 2006 to 2014, which was that transition period. But if you look at the trend line, which is the solid black line that goes across the entire page, we can see that there has been a steady increase. Two graphs side by side, we can only look at the left one from 1972 forward because that is the limiting year on the right graph. But it is very apparent that there is a direct correlation between the growing population and the number of depredation events. As the population of mountain lions increase, the depredation events increased. From 1972 to 2019, the population of California increased from 20.5 million to 39.4 million, meaning the population has almost doubled, which means that there's more people living on suitable mountain lion habitat. And with the increasing mountain lion population, there's inevitable conflicts between lions and humans. In the paper Temporal Trends, it was shown that there's a positive correlation between the removal of a lion and depredation events the next year, meaning that if a lion is killed for depredation reasons, it creates a gap in the food chain which allows younger lions to come in, and they're going to kill the slower easier prey, which is going to be people's livestock and pets. So to prevent these lethal depredation events, we need to have better animal husbandry practices such as stronger fences and pinning animals in enclosures nightly, which would reduce the amount of human-lion interactions. Additionally, agencies such as the Department of Fish and Wildlife should continue researching ways to deter mountain lions from depredation, which would lower the lethal rate of removal.